Okay. Okay, so calculus is a topic where we find slopes of curves and area underneath curves, because then that tells us a lot of information. So we're going to today look at average velocity and instantaneous velocity, a little bit on limits. Did we talk about limits earlier this year? A little bit? I don't remember. And then talk about tangents line. Average velocity is super easy. It's the change in position divided by the change in time. So S of t is position at a certain time. So if S of 1 equals 7 and S of 4 equals 16, okay? If we want to find the average velocity, well, we take 16 minus 7 over 4 minus 1, because this is the position, this is the time. Okay, so it's the change in position divided by the time. What's 16 minus 7? 9 divided by 3 is 3. And an average velocity of 3. Okay, if it's miles, then it'd be miles per second, miles per minute, miles per hour, whatever. Okay, average velocity. Okay, a limit. A limit is as you get really, really, really close to a point, that number approaches some number. Okay, as you get really, really, really close, a number approaches some number. So as we get close to this x-axis, this goes up and is an asymptote, so it approaches infinity. Okay, as we get really, really close to 0, so the limit of our function as x approaches 0 is going to be infinity, because it goes up forever. So because is this ever going to hit infinity? No, it's not. Okay, there's other ones where you have a hole in the function. So as we get really close to this hole, it might be 1. The hole might be at 1, but because there's a hole there, we never actually at 1. But we can say the limit of this function as it approaches, let's say it's approaching 2, it equals 1, because we get really, really, really close to 1. Okay? All right. So we're going to use limits to find the slope of a tangent line of s equals t cubed. What's the graph of s equals t cubed? Well, it's 0, 0 is a point, 1, 1 is a point, 2, 8 is a point somewhere up here, -1, -1 is a point, -2, -8 is a point down here, so it looks like this. Okay? That's what it looks like. So what is the slope of the tangent line at this point? Okay? How do we find that slope? Can I change color here? I don't know if I can. So what we're doing is we're finding the slope right here. Okay? The slope is about right there. Okay? That's my tangent line. So what's the slope there? Because the slope of that line will be different than the slope up here, because that one's more like this. Okay? So when you're taking the slope of a curve, it constantly changes, the slope does. Okay? So what we do is we find the limit as it gets close to it. Okay? So the slope equals the change in y over the change in x. Rise over run, right? Well, the change in the y goes from t cubed minus 1 over the change in x is t minus 1. Okay? And you go, well, where did you get that from? Well, when I'm really close to here, t changes. Okay? Because if I wanted to find the slope between 0 and 1, between 0, 0 and 1, 1, I'd just take y2 minus y1 over x2 minus x1. Because this is x1, y1, this is x2, y2. And I find the slope of 1 over 1, which is 1. Okay? But I'm not finding that slope. I'm finding the slope between an arbitrary point that's moving here and the point 1, 1. And why do I move the point? So I can get a little more close, a little more exact. Okay? So, can we factor t cubed minus 1? And the answer is, yeah, we can. Into t minus 1 times t squared plus 1t plus 1. That's how it factors. That you learned back in Algebra 2. You remember that? No. Divided by t minus 1. Now, if we did the limit here, what's my issue? If I put the limit of 1 in here, what do I get in my denominator? 0. Can you divide by 0? No. Everything is all great in the world until somebody tries to divide by 0. Nah, it doesn't work. But what we can do is once we factor this out, we can cancel these out. Then if we want to find the limit as x approaches 1 of t squared plus t plus 1, we put a 1 in here, we get 1 plus 1 plus 1, which is 3. So at 1, 1, the slope of the tangent line is 3. Okay, the slope of the tangent line is 3. And look, they got the same answer as me, doing the same process. Whoops. Okay. Let's say we have 3x squared minus 5. What does the graph of 3x squared minus 5 look like? Well, if we put in a 0, we get negative 5. If we put in a 1, we get negative 2. If we put in a 2, we get 7. So it's a parabola looking like this, right? Okay. Now, for some reason, we can figure out that at x equals negative 1.3, we're on the graph somewhere. Negative 1.3, because at negative 1, I'm down here. I wonder where negative 1.3 is at. Okay? So, if we take 3 times negative 1.3 squared minus 5. Somebody, calculator, help me out. Anybody have a calculator out? Hey, Cameron does. All right. Thanks, Cameron. Take 3 times. How'd you get that so quick? You punched that into your calculator? Really? Okay. 0.07? 0.07. Wow. Okay. So we're right about negative 1.3, 0.07 is about right there. Okay? We want to find the slope right there of that line. Okay? So let's try to do it. Okay? So what I'm going to do is go from some other arbitrary point right here. What other arbitrary point am I at? Well, I'm at like x, and then just a second. Let's just go say that I'm xy for this second. Okay, so find the slope. It's y2 minus y1. So my y2, let's say, is this. So 0.07. Well, let's just go it this way. y2 minus y1. So 3x squared minus 5 minus 0.07 over x2 minus x1, which is x minus a negative 1.3. They gave us some hard numbers. That's kind of stupid. Because that's really hard to factor. So I'm going to erase it and we're going to look at their work because, yeah, it's just hard numbers to work with. So this is where we're at. This is what I just wrote down is this, okay? So I get 3x squared minus 0.507 over x plus 1.3. And then doing the limit, if we factor this and these two cancel, I get 3x minus 3.9. How would you know how to factor that? I don't know. Because they give us such hard numbers. You put the 1.3 in and it works out to be negative 7.8. That's the slope. Okay? I'm not going to give you a problem quite like that. But I am going to make you find a tangent line. So once you find the slope, you put it in point slope form. And then you solve for y. Okay? So we'll look at that in a little bit. Average rate of change is a slope, basically. Change in y over change in x. Okay? So that's the slope of a secant line through 2 points. Now, a lot of times, this is kind of hard to work with. Okay? So we have a different derivative formula. Okay? The derivative is always the slope. So in AP Calc, when I talk to the AP Calc kids, I keep talking about them and harping on it. If you see slope, think derivative. If you see area, think integral, right, Ashlyn? Okay. But this formula is kind of hard. And you're going to say, well, the next formula is even harder. But the next formula is called the difference quotient. Has anybody taken college algebra in here yet? None of you? Okay. College algebra next year, you're going to have to work with this function. Okay? You're going to have to work with this function called the difference quotient, which helps you find derivatives of functions. Okay? So this is the difference quotient. Okay? And I'll help you out with that. Okay, let's use the difference quotient to find the derivative of this function here. Okay? So we take f of x plus h minus f of x all over h. F of x plus h is 2 times x plus h plus 4. That's f of x plus h. Okay? Because whatever goes in here goes in for the x. Okay? Minus f of x, which is 2x plus 4, all over h. And look at that. I already gave you the answer. Quit that. All right. So if we distribute, we get 2x plus 2h plus 4 minus 2x minus 4 all over h. What happens is our 4's cancel and our 2x's cancel, and I get 2h over h, which is just 2. What's the slope of this function? The slope of that function is 2. Why? Well, y equals mx plus b. Slope is 2, right? First derivative is 2. Okay? All right. Then if we were told to find the tangent line, we don't have to worry about that right now. Okay? Let's find the slope of this one, the derivative of this one, because we're not finding slope because we don't have a point to find slope at. So let's find the derivative of this one. So f of x plus h minus f of x all over h. So 2 times x plus h squared minus 2x squared all over h. So what's x plus h squared? Well, it's x plus h times x plus h. X plus h times x plus h, x times x is x squared. Outers is xh, inners is xh. What's 1xh plus 1xh? 2xh plus h squared minus 2x squared over h. So you get 2x squared plus 4xh plus h squared minus 2x squared all over h. What happens with our 2x squared and negative 2x squared? Cancel. And we factor out an h out of 4xh plus h squared. Those cancel. So your derivative is 4x plus h. So if you're told where your h is, then you just plug it in. So if you're going towards 0, then it would be 4x. Okay. Discard. So let's look here quick at some of the homework problems that you'll see, and then we'll get started. A bicyclist travels 7 miles in an hour and 45 minutes. What's the average velocity during that time interval? Well, it's a change in distance over the change in time. And you just divide. Okay? Easy peasy lemon squeezy. This one. We want to find the estimate of the slope at x equals 3. Right here. What's the slope right there? Well, if we draw a line that hits it just right there and there only, what does it look like the slope of that line is? Approximately 1. You rise 1 and run 1. Okay? Now, if they would say, what's the slope up here somewhere, then it would obviously be a higher slope. Okay? Looking at this function, you would graph it on your graphing calculator to figure out which one it is. And I think that it's this one. Okay? So they say at 2, at an x value of 2, is the slope positive, negative, or 0? Well, an x value of 2, what's your slope going to be? What's your tangent line going to be? It's going to go like this. So your positive slope. At 0 here, you're going to have 0 slope. Okay? And this one never happens to be negative. Okay? Then they say, use this function to find the slope of this. And our h is going to go towards 0. Okay? So 7 times x plus h plus 4 minus 7x plus 4. So the only difference between these two is the x plus h all over h. So 7x plus 7h plus 4 minus 7x minus 4, if we distribute the negative sign, all over h. The 7x's cancel, the 4's cancel. I get 7h over h, which is just 7. Okay? I'm going to do the same thing here, and then find the tangent line, and then look at the graph. So, f of x plus h minus f of x all over h. So 4 times x plus h squared minus 4x squared all over h. So it's 4 times x squared plus 2xh plus h squared minus 4x squared all over h. So it's 4x squared plus 8xh plus 4h squared minus 4x squared all over h. The two 4x squareds cancel. So I get 8xh plus 4h squared over h, which is 8x plus 4h. Now, if the limit as h is going towards 0, If h is going towards 0, we put a 0 in there, then that disappears. So the slope is 8 times x. Or in this case, the slope at -2 is 8 times -2, or -16. So if our slope is -16, then if we want to find the tangent line there, the slope is -16, and our point is -2 something. -2 what? Well, if we put a -2 in here, -2 squared is 4. 4 times 4 is 16. Then you use point slope form to find the tangent line. Y minus 16 equals -16 times x minus -2. So y minus 16 equals -16x minus 32. Add 16, y equals -16x plus 16, or minus 16. Y equals -16x minus 16. So which one has a slope of -16? And you're at -2? Well, it would be C. Okay? And then you do the same for that.